Hello, and welcome to our course on data visualization. In this course, we are going to study what is data visualization, when to use it, why it is important, and then we are going to present various data viz techniques that will allow us to better understand the data and extract useful insights from it. The course is divided into 7 parts, including this first class that introduces the area, discusses its importance and when to use it, and presents the main data sets that will be used to illustrate the techniques described here. We are going to start talking about data visualization. And to do that, I'm going to present a brief introduction of what is data visualization, and I'll present to you the data sets that we are going to use in this class. And after that, we are going to have the presentation of 6 different types of data visualization tools. We are first going to work with distributions, then associations, amounts, proportions, evolution and flow, and geospatial data. All these are related to different types of data and different types of graphs. Starting with an introduction to the field. First thing, what is data visualization? This is basically the representation of data using a sort of pictorial or graphical format that we are going to call here generically as a graph or a visual. And another important question is, when should we use visualization tools or data visualization tools? There are mainly 4 cases in which these tools are useful. One of them is when we have quantitative values that you want to examine, but in order to search for patterns or trends or any specific shape of the data or the relationship between different types of variables or different types of data. Also, we usually employ data visualization tools when we can deal with a single unit of measure. And the reason why I place it here this way is because when you have variables spanning different types of ranges or using different types of measures, let's say I've got height measured in feet and inches or in meters and centimeters, and then I have the weight measured in kilograms or measured in pounds, you usually cannot place these 2 types of variables in a single graph because they are represented by different units of measure. So you can use a table to represent them, but you cannot use a graph or a single visual to represent them, unless you use different scales on the left-hand side and on the right-hand side of the same visual. That's also possible, but that's not very common. The possibility of using a single unit of measure is something important when you're representing data using graphs. And of course, you can also achieve this by simply normalizing our variables within the same interval. And then after they are normalized within the same interval, you can represent them in the same graph, right? But it's what happens when you normalize a variable is that you lose the direct perception of the value of that variable. Let's say that, for example, you normalize the height of people within the interval 0 and 1. So if you say someone is 0.8 height, what does that mean in real terms? And then we also use data visualization when you're looking for or you're searching for specific patterns in the data. For example, you can be looking for anomalies, for outliers in your data, and also when the volume of data is too large for a table. Tables are very interesting when you want to compare variables one by one, side by side, but they're not very useful when you have such a large amount of data that the table is going to cover many and many pages or a very large file. These are situations in which data visualization tools are very useful. And what's the importance? Well, data visualization is important because it allows us to find or discover trends in data. For example, we can find variables that have long tails, and usually long tails are a synonym of outliers in the data. You can, for example, try and find to see if a given variable has a normal distribution or has any specific predefined distribution. Data visualization is also interesting to make complex data understandable. This is because you have this visual representation of the data, and the visual representation of the data can allow you to uncover specific patterns. For example, it allows us to find relationships between variables using correlation measures or using linear regression analysis. It can also help you have different perspectives on the data, to put the data into a context. It can save you analytical time. This is something interesting because people talk a lot about machine learning, talk a lot about the use of algorithms in order to make inferences about the data, to make classifications, to do clustering, to do recommendation, to do different types of analysis. But what happens is that sometimes with a very simple visualization of a data or a specific variable, you can find an outlier, you can find anomalies in your data. You can, for example, estimate the value of a given variable over time by simply plotting the values of that variable over time. So you can do this extrapolation, you can do this inference simply based on a specific curve. And also, and very interesting, the visuals allow us to tell stories about data due to their very nature of being a visually appealing way of representing your data. So you can plan and make a narrative around your data using the visuals that you created. In this course, I am going to work with some well-known data sets from the literature, and they will be used in different parts of our presentation. The first one is the iris data set of Fisher. So this is a very simple data set containing only 150 objects or samples, 4 independent variable and 1 dependent variable that corresponds to the plant species. And here we have the iris setosa, iris virginica, and iris versicolor that is not being shown here in this sample table. The 4 variables are the sepal length, the sepal width, the petal length, and the petal width. Here is the link if you want to download or if you want to have a look at this data set. You can find it here at the University of California at Irvine Data Repository. The other data set is the AutoMPG data set. This is basically a data set that brings information about different vehicles. In this case, we have 398 vehicles in our data set, and the variables include the miles per gallon, the number of cylinders, the displacement of the car, the number of horsepowers, the weight, the acceleration, the model year, and the origin of the car. Okay, and the car name. So, but the car name is an ID. It's usually only an ID variable that is not used when we are doing analytical processes because it's like the object number. Unless you have many cars with the same name, in this case, we have a single car with each name in this table. This variable is usually discarded in our analysis. This is also a data set from the UCI repository at the University of California at Irvine. We also have the Gapminder dataset. The Gapminder dataset, it brings us geopolitical information about some countries in the world. Here we have 3,675 objects, and the informations include the life expectancy, the human development index, the consumption of carbon dioxide per person, the GDP, and the level of services in these countries. One important feature of this data set is that this data set spans over many years, and this allows us to make analysis of what we call time series analysis, which are analysis over time. So that's an important feature of this data set. And this data set was downloaded from Kaggle. Here is the link from Kaggle, but we can also find the data set and information about it in a website called gapminder.org. And finally, we have the Natural Earth data set. This is the low resolution version of this data set. And this data set is available at the GeoPandas Python library. So you can simply load this data set by importing this library into your file. And in this case, we are working with 177 objects of this data set. This also brings information, some geopolitical information, like the estimated population size of some countries, the ISO, the GDP, And the geometry here is related with the shape of the country when plot in a map, right? We'll use this data set particularly to discuss some map visualization techniques. Thank you for watching and see you in our next class.